In this question, we are asked to find three pieces of information about this polynomial. We're asked to rewrite it in standard form, identify its degree, and identify its leading coefficient, which is abbreviated as LC. This particular polynomial has two terms. There's the 4 and the negative 7z. It is important to remember that negative signs always belong to the number that comes after them. When we're rearranging these in standard form, we're rewriting them with the letters and the largest exponents coming first. In this case, the negative 7z has a letter, so it would come before the 4. So to rewrite in standard form, we would write negative 7z plus 4. The reason it's a plus 4 is because this 4 is positive. So rewritten in standard form, our polynomial looks like this. Once rewritten in standard form, it's easy to identify the degree and the leading coefficient. The degree is the largest exponent in the polynomial. In this case, there's no exponent next to the z, so we can assume it is a 1. So the degree of this polynomial is 1. The leading coefficient is the coefficient of the degree. So in this case, since our degree is 1, the leading coefficient is negative 7, the coefficient of the variable with the highest degree. The same exercise with a different polynomial. There are two terms, 6x to the third power and negative 4. To put them in standard form means to rearrange them with the largest exponent coming first and then going in a declining order. So in this case, the largest exponent is 3, so the term 6x to the third comes first, followed by the other term, the minus 4. This one was already written in standard form to begin with, but we rewrite it in standard form just to make sure we answer clearly. The degree of this polynomial is 3 because that is the largest exponent in the polynomial, and the leading coefficient is 6 because that is the coefficient of the variable with the degree. Our third example features three terms, three monomials, negative x squared, positive 2, and positive 18x. To put this in standard form, we rewrite it with the largest exponent coming first. In this case, the largest exponent is 2. So we'll start with the term negative x squared. The next largest exponent is the invisible 1 attached to the 18x. Letters always come before numbers in polynomials. So plus 18x will be our second term. And our third term will be the plain number, plus 2. The degree of the polynomial is 2 because that is the largest exponent, and the leading coefficient is actually a negative 1. Remember, if there's no number in front of a letter, it's like an invisible 1. In this case, since we're talking about negative x squared, it's like having negative 1x squared. In our fourth and final example, we have three terms again, a negative 6, a positive 13y to the 5th, and a negative 2y to the 4th. To put them in standard form means to rearrange them with the largest exponent coming first and then working our way down in descending order. In this case, the largest exponent is a 5, so we'll begin the problem with 13y to the 5th. The next largest exponent is a 4, so we'll continue with minus 2y to the 4th. And finally, the last term will be the plain number, the negative 6. The degree of this polynomial is 5 because that is the largest exponent, and the leading coefficient is 13, the coefficient of the variable with the highest degree. Once you put these in order so that the biggest exponent comes first, the degree and the leading coefficient will always be pulled from that first term that you see.